Hi all the students of Narayan and 9th standard. Today here I am in front of you all to discuss the assignment number 39, and it is from the topic center of mass and collisions. Now let us go into the first question of your assignment. The first question of your assignment is over here. A man of 50 kg is standing at one end of a boat of length 25 meters and mass 200 kgs. If he starts running and when he reaches the other end, he has a velocity of 2 meter per second. He is running with velocity of 2 meter per second on the boat, and it is of length 25 meters. And with respect to the boat, the final velocity of the boat is, he wants it in meter per second. Now when you want such kind of problems to be solved, it's a task which you have to find it out like let's write down that the mass of the man is given as mass of the man. We'll write it as mm, mass of the man, which is given as 50 kg, right? We'll write 50 kg, and mass of the boat is given as 200 kg. 200 kg, it is given as 200 kg, and this is 50 kg, right? Now what happens if you want to find here again velocity of the man is given as, we'll write it as Vm, which is equals to 2 meter per second. 2 meter per second. And do you know the velocity of the boat? Now we have to find out the velocity of boat, question mark. Now when you get this kind of questions, you just better go with this law of conservation of momentum. Law of conservation of momentum. Law of conservation of momentum. Now when you go with that, then you have to have like m1, that means the mass of the man into velocity of the man is equals to total system mass, which is mass of the boat, plus mass of the man into the velocity of the boat. Now this is law of conservation of momentum. Now when you go with this, mass of man is given as 50 and velocity of that particular person is given as 2, which I can write it like 100, and that is equals to mb is mass of the boat, which is 200, and mass of the men is given as 50 into Vb. Now let us try to solve this. When you solve this, you are going to get 100 over here, and over here you are going to get 250. Now I want V. When I want Vb, that means the velocity of the boat, then I will try to find out Vb is equals to 100 by 250. So what happens? 0 0 gets cancelled. 5 2s are 5 5s are. It is 2 by 5 meter per second. So velocity of the boat is 2 by 5 meter per second. 2 by 5 meter per second. Now which option it is? First option. Hope this is helpful for you. Let us get in the next problem. Now here your second question. When coming to your second question, two particles are there, A and B, initially at rest, moves towards each other under a mutual force of attraction. At the instant when the speed of A is v and the speed of B is 2v, the speed of the system is, actually they both are in a system, like this is in one system and this is also in one system. This is moving with some velocity v and this is moving with some velocity 2v. Now this completely is a system, right? The complete system, the internal forces can't change the center of mass, so your center of mass is not going to change. The speed of the system is, the internal forces can't change the speed also, so the speed of the system is 0. So the speed of the system is 0. I hope it is clear for you all. Internal forces cannot change the center of mass, so the speed of the object's speed is also 0, right? So let us go with the next question. Next question over here for you all is in this question they have given you masses m1, m2, m3 and m4, and they are situated, their locations also they have given, like 2, 1, 1 and 1, 2, 1 and 2, minus 2, 1 and minus 1, 4, 3. They have given all the 4 positions, and if their center of mass is situated at, they have given you the center of masses also. Let us think this is x center of mass and this is y center of mass and this is z center of mass. Now x, y, z center of masses they have given. Now they also gave you the masses like m1, m2, m3 and m4, and also they gave you x1, y1, x2, y2, sorry, x1, y1, z1, x2, y2, z2, so on. Sorry, these are locations x1, x2, so on. They have x1, y1, x2, z1 and x2, y2, z2 and x3, y3, z3, x4, y4, z4. They have given you the coordinates. Now what you have to do is, now let me remove all this. I need only this value, which is m value, which is the mass of the fourth object. Now when I want to find the mass of the fourth object, I will take any of the component. Now I will take any of the center of mass axes. Through the axis I will take x center of mass, because we have one, or it is easy for you to find out. You can take also y also. Now let me take, I will take the mass m1, like x center of mass, we know the formula. X center of mass formula is m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by m1 plus m2 plus m3 plus m4. Now we have 4 masses. So what we do, we will just try to substitute these values, like 1 into x value is how much? 1 into x value is 2 plus 1.5 into 1, m3 is 2 into x3 is where is it? x3 sorry, x1 is 2, x1 is 2 and x1 is 1, x2 is 2 and x3 is this one 2, right? Now x4 is minus 1, so I will write it as plus. M4 is capital M, and we have M also 2, 1.5, 1 and M, x4 is how much? X4 is minus 1, so minus 1 by, we will take 1 plus 1.5 plus 2 plus M. X center of mass is given as 1, so this is that, so I will substitute that value as 1. Now what we will do, we will just try to multiply it. 1 into 2 you will get 2, 1.5 into 1 you will get 1.5 plus 2, 4 you will be getting here 4 and here minus M. And what happens over here? 4, 5, 6, 7.5 minus M, and here 2, 3, 4.5 plus M. Now what happens, you just, if this is getting divided this side, you send it that side and you are going to get 4.5 plus m is equals to 7.5 minus m. So you will get 2m, which is equals to 7.5 minus 4.5. So you will be getting somewhat around 7.5 minus 4.5, 0, 3 you will be getting. So this is 3 is equals to 2m. So you will get 3 by 2. M value is equals to, M value is 3 by 2. So when 3 by 2 means you will be getting somewhat around 1.5 kg. Mass, no, it is has to be in kg. So your total mass is 1.5 kg. So the option is third option. Hope this is helpful for you. Let us meet in the next assignment. Until then, bye.